Mixtures are not chemically joined, they can be separated using physical processes. These processes do not involve chemical reactions, they simply separate substances that are already there. But how we separate a mixture depends on what kind of mixture it is. Let's start with filtration. Imagine mixing sand and water. The sand does not dissolve, it just sits there. To separate them, we use filter paper. The paper has tiny pores. Water molecules can pass through easily, but the sand particles are too large, so they get trapped. This is how filtration separates an insoluble solid from a liquid. Next comes crystallization. Now imagine salt or copper sulfate dissolved in water. You can't see the solid anymore, it's fully dissolved. To get it back, we gently heat the solution. As the water evaporates, the solution becomes more concentrated. Eventually, solid particles begin to form again, arranging themselves into crystals. If this happens slowly, the particles have time to form neat, ordered patterns, creating larger, clearer crystals. This method is often used to make copper sulfate crystals in the lab. Now let's look at simple distillation. Think about seawater. It looks like one substance, but it's actually water mixed with salt. Salt has a much higher boiling point than water. When seawater is heated, only the water evaporates. The water vapor moves away, cools down, and condenses back into liquid water, now pure water. The salt stays behind in the flask. That's simple distillation, separating a solvent from a solution. But what if a mixture contains two liquids? That's where fractional distillation comes in. Imagine a mixture of ethanol and water. They both evaporate, but at different temperatures. As the mixture is heated, vapors rise up a tall column that is hot at the bottom and cooler at the top. Each liquid condenses at a different height depending on its boiling point. Liquids with lower boiling points, like ethanol, condense first and are collected at the top. Liquids with higher boiling points, like water, condense later. This same idea is used on a huge scale to separate crude oil into useful fuels. Finally, let's explore paper chromatography. Imagine you place a tiny dot of ink on a pencil line drawn across paper. When the paper is placed in a solvent, the solvent slowly travels up the paper, carrying the ink with it. But here's the trick. Different substances in the ink move at different speeds. Chromatography works because there are two phases, the stationary phase, the paper, the mobile phase, the solvent moving through the paper. Each substance is attracted differently to these two phases, so they separate as they move. The result is a chromatogram. This chromatogram can tell us a lot. A pure substance produces one single spot. A mixture produces two or more spots. Chromatograms can also help identify substances. If two samples produce the same number of spots with the same colors and the spots travel the same distance, then the substances are likely to be the same.